Okay, this is the second lesson for Chapter 5, Intro to Polynomials. There we go, that's better. Okay, so just a review from Lesson 1, asking you how many terms are there in each expression. So remember, every time you see a plus sign or a minus sign, it's the start of a new term. So this has 3 terms, so it would be called a trinomial. Every time we see a plus or minus, starts a new term. This has 2 terms, so it's a binomial. This has 1, 2, 3, 4, 5, 6 terms, so it is just called a polynomial. No special name for that one. Okay, so that should be a review. If it wasn't a review, maybe you need to watch Lesson 1 for the first time or again, or come see me at lunch and we'll go over it. Okay, so now it says circle the term that can have only one value. And so what I mean for that is when we look at A, well, A can be anything. We can assign it to be 5 or 7 or -2. And the same for B. They're variable. Their value can change. So the only thing in this first expression that has a value that can't change is the +2. No matter what, it will be +2. Looking at the second expression, we have 7c squared minus 6. So the only thing in that expression that can't change is the -6. That first term might multiply to different things depending on what c is. Looking at the third example, we have 1, 2, 3 terms. 2x squared y plus xy plus 5. Plus 5 is the only thing in that expression that will not change. -8w cubed minus 8 plus w. -8 is the only thing that will not change. That value will remain. We would say that the value stays constant. So because the value stays constant and does not change, these values are known as constants. Their values never change, ever. Never, ever, 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 ever. Okay, so in case you caught that, constants is one of your key terms. You need to know that. Your next key term is coefficients. And so the coefficients go with a variable. Oh. They are also known as a multiplier because they multiply the variable. Okay? And so in the first example, this is like saying 2 times x. So the coefficient is 2. We have 5 times x squared times y squared. 5 is the coefficient. -7 times t to the power 4. So -7 is the coefficient. Notice that the sign goes with the value. 4 times a times b times c. 4 is the coefficient. And -14 times x cubed times y cubed times z cubed. -14 is the coefficient. If you just said 14, you would only be partly correct. So coefficient is another keyword, key term that you do need to know. Okay, we're going to investigate the exponents. And so on the first example, we have an exponent of 2. That means our variable x is repeated twice. For b, we have an exponent that's not really shown. If the exponent isn't there, it's an exponent of 1, so that means x is there one times. On c, we have an exponent of 5, so our base of y would be repeated 5 times. On d, we have an exponent of 13, and on k, we have an exponent of 1. So being able to recognize the exponents is important, and especially on these examples, many of you will say, oh, there's no number written there, so the exponent is 0. It's not. We just don't write the 1. It just means that it's there one time. So we don't write an exponent of 1. If we were saying an exponent of 0, remember anything to an exponent of 0 has a value of just 1. Okay? And we would need to actually show the exponent of 0. Okay, another keyword. I told you there's a lot of vocab in this one. And so the degree of the term is the sum, and sum is when we add the exponents on the variables in a term. So it's only on the variables. If the constant had an exponent, we would ignore it. And we only add them within a term. So notice all these examples below are monomials. They only have one term. If we had multiple terms, we would only add within the term. We wouldn't jump across terms to add. So in the first example, it's nice and easy. We have x to the power of 3. So this is a degree 3 polynomial. Pardon me, degree 3 term. I guess degree 3 monomial. When we look at the second example, we have squared and squared, so we need to add. So this term has a degree of 4. We need to add the exponents. When we go to the next example, we don't worry about the coefficient. We only look at the variables. So we have a degree of 5. Again, ignore the coefficient when we're looking for the degree, and we have a degree of 8. On our next example, this is like x to the power of 1 and y to the power of 1. So this gives us a degree of 2. A degree of 9, a degree of 4, and a degree of 1. So the term is a degree 5. Ignore the coefficient, a degree of 1 and a degree of 3. So the term is degree 4. So we're going to start combining terms now and look for the degree in the polynomial. And so the degree in a polynomial, another key term, is equal to the highest degree in the term. So there's no adding across terms. Many of you will confuse finding the degree of a term and defining the degree of a polynomial. So be careful on that. So the first thing I want you to do is you're going to split up the polynomial into the separate terms. So in this one we have 1, 2, 3 terms. We only worry about the degrees on the variables. So we have a degree 2 and we have a degree 1. So this polynomial is a degree of 2 because 2 is the highest degree term. Looking at the second one, splitting it up into the terms, we ignore the coefficients, only looking at the variables, so we have a degree 3 and a degree 1. So that means this polynomial is a degree 3 because that's the highest term. Split it up, we have a binomial. Don't need to worry about the coefficients. We have a degree 4 and a degree 3. So this polynomial is a degree 4. Again, splitting into terms. We have a degree of 1 and 1, so we have a degree of 2 and a degree 1. So this polynomial is degree 2. We have a degree 2, we have a degree 2, and we don't worry about the constant. So this polynomial is degree 2. Lastly, 2 terms, we have a degree 6 and a degree 5. And so this polynomial is a degree 5, or pardon me, degree 6, because 6 is the highest term. So that's your second lesson. Not a ton of practice questions. Lesson 3 and 4 will be assigned for tomorrow.